Hi, welcome back. In this video, we're going to come up with a new differentiation rule for general logarithmic functions and also for the natural logarithmic function. So we need a derivative for the function y equals log base b of x, where b is some positive real number other than 1. So we're going to do it the same way we did it for inverse trig functions. Remember, the log base b of x is the inverse function of b to the y is equal to x. These are inverses of each other. So we're going to use implicit differentiation on this second equation. The derivative with respect to x of b to the y is equal to the derivative of x. Remember, y is a function of x, so we're using implicit differentiation. So on the left side, it's the derivative of the outside. Using our rule for exponential functions, it's b to the y times natural log of b, but we have to multiply that by the derivative of the inside function, y prime. And that's equal to the derivative of x, which is just 1. So now we just divide both sides by b to the y times natural log of b, and we get y prime is 1 over b to the y times natural log of b. But then we go back, we know b to the y is just x. So we get y prime is 1 over x times natural log of b. All right, so we just came up with this new rule. The derivative with respect to x of log base b of x is 1 over x times the natural log of b. All right, so now what if we wanted a rule for y equals the natural log of x? We just have to remember the natural log of x just means base e. So using this same formula but letting b be equal to e, we know that the natural log of e is just 1. So we can rewrite that formula as the derivative with respect to x of the natural log of x is just 1 over x. All right, so now we're going to do a few examples using these two new rules. So the first one says y is equal to the square root of log x. There's no base. Well, this is notation, I hope you remember, this just means the common log, or log base 10. So we reviewed this in chapter 1. Log with no base just means log base 10, and you probably have a button on your calculator that just says log x or just log. That means log base 10. All right, so we're going to use the first rule that we just learned. The derivative of log base b of x is 1 over x times the natural log of b. So, but we're also going to have to use the chain rule because we have an outside function, the square root function. So let's do that. Y prime is the derivative of the outside, which means the derivative of the square root function, with the inside unchanged, times the derivative of the inside. So now we're using our new formula. The derivative of log x is 1 over x times the natural log of 10. And that's it. We could combine, multiply those two fractions together, write it as 1 over 2x natural log of 10 times the square root of log x. All right, let's do another. So in this one, we're going to differentiate f of x equals the natural log of the cosine of x. So we're going to use the second differentiation rule that we just got. d dx of natural log of x is just 1 over x. But we also have to use the chain rule because we have an inside function. It's not just x, it's the cosine of x. So the derivative, f prime of x, is going to be the derivative of the outside with respect to the inside, so it's just 1 over cosine of x, times the derivative of the inside. So the derivative of cosine is negative sine. And then if we rewrite that as a fraction, negative sine x over cosine x, we recognize that as negative tan x. All right, Let's do just one more. In this one, we're differentiating the function g of x equals natural log of the natural log of x. So again, we're going to use our second new differentiation rule. The derivative of the natural log of x is 1 over x. But we have two nested natural log functions, so it's a chain rule again. We're going to do the derivative of the outside with respect to the inside multiplied by the derivative of the inside. So g prime of x is 1 over the natural log of x times 1 over x. And if we want to simplify, we just multiply the two fractions. We get 1 over x times natural log of x. All right, we'll do one more video on differentiation of logarithmic functions using a little bit of an algebra trick to simplify our work. And I'll see you there.